Hello, good morning, guys, and welcome to our 13th session of our subject ITAS 1. So we are now on unit number 3, chapter 10 of our subject, of our discussion. And our topic for this morning is about application lifecycle. So before we, general software development, before we start our discussion, guys, let's hear about our objectives. So number 1, we're going to identify and explain application lifecycle. Second, appreciate the use of data structure in programming language for solving mathematical algebraic problems. And number 3, design, develop, implement, test, and debug a program using different testing levels and methods. So application lifecycle is a broad topic wherein you have several topics that we have to understand and discuss. But in fact, application lifecycle is the product lifecycle management. So it means we are using it for governance, development, and maintenance of computer programs. It also encompasses requirements management, software architecture, computer programming, software testing, software maintenance, change management, continuous integration, project management, and release management. Now, when we talk about application lifecycle versus the software development lifecycle, so what is the difference between the two? ALM is a broader perspective than software development lifecycle or SDLC. So it is limited to the phases of software development, such as the requirements, design, coding, testing, and configuration. So we have also project management and change management. Now, your application lifecycle continues after development until the application is no longer used and may span many SDLCs. So, application lifecycle is more encompassed within the SDLC. And its functionality doesn't limit only to the application stages of the SDLC, but also in the configuration of the lifecycle wherein you'll be able to understand and configure the changes and the perspective of systems development. So let's talk about integrated ALM first. So modern software development processes are not restricted to those discrete steps of the ALM or SDLC. However, they differ in using multiple tools from different locations. So these are the examples of the differences. We're in real-time collaboration, access to centralized data repository, the cross-tool and cross-project visibility, and you have also better project monitoring and reporting are the key development quality software in less than time. So this has given rise to the practice of integrated application lifecycle, or the ALM, wherein all the tools and the tools users are synchronized with each other throughout the application development stages. So this integration ensures that every team member knows who, what, when, and why of the changes made during the development process, and there is no last-minute surprises causing delivery delays or project failure. For today's application management, vendors focus more on API management capabilities for third-party best-of-breed tools integration. So this ensures that organizations are well equipped with internal software development system that can easily integrate with IT or ALM tools needed in the project. Now, such research director with research firm Gartner proposed changing the term ALM to ADLM. So instead of application lifecycle management, we have application development lifecycle management. So this includes developmental operations and software engineering culture and practice that aims at unifying software development and software operation. So, however, there are some changes or configuration for that, and we don't need to discuss it, guys, but we'll just discuss some of the applications for ALM. Now, before we go to our first topic for ALM, let's discuss first the benefits of ALM. So number 1, it provides direction. So applications lifecycle management provides a clear direction for the application before it is built, and develop the business cases, the plan resources, and the map and lifespan of the application before committing to development. So all of this saves time and money by avoiding costly mistakes and unneeded features. The second one is the speed and agility. So without ALM, teams could never produce software at the speed and agility needed but to stay competitive. However, integrated systems run much more effectively than unconnected tools and processes across multiple teams. So the integration improves the communication and helps align software objectives with business goals. Now you have better decision making, and ALM also help businesses take better decisions as the software ages. So with features like version control and real-time planning, so this is found in many ALM tools, the team's leaders quickly and decisively map out the app's future. Now these decisions are amplified when the businesses that has multiple applications, making ALM all more important. Okay. Now, for our first topic will be for ALM is requirements analysis. So let me tell you guys before we start that ALM has more applications other than that. We only choose two. That is requirements analysis and design process. Now, for requirements analysis in systems engineering and software engineering, requirements analysis focuses on the tasks that determine the needs or conditions to meet the new or altered product or project. So this is taking into account of the possibility and conflicting requirements for the various stakeholders. So you have analyzing, documenting, validating, and managing software requirements or systems requirements. And requirements analysis is very critical to the success or failure of a system or software project. So the requirements should be documented, actionable, measurable, testable, traceable, related to identified business needs or opportunities, and defined to a level of detail sufficient for system design. So conceptually, the requirements analysis includes three types of activities. So the first one is eliciting requirements. Example of eliciting requirements are project charter or definition. So you have business process documentation and stakeholder interviews. So this is sometimes also called requirements gathering or requirements discovery. For eliciting requirements, guys, if you are talking about government procurement, then you must have a program charter to start the project cycle, or the project paper, or the project blueprint for the project that is being attached into cyclical development. And mind you guys, the project charter is very important because you'll be able to identify and to lessen the burden of gathering materials. So it's there already. All you have to do is to gather the information for requirements. Thus, you have completed the first step initially, and of course, you're on the way to developing the project. For the second naman is the requirements or recording requirements. These requirements that they may be documented in summary list, and it also include natural language document, use cases, user stories, process specification, and variety of models, including data models. So recording requirements is very important, especially the use cases. The importance of that is when somebody or a programmer is not able to continue developing the system or the project will not suffer because you know how to read use cases. So the programmer, for example, can be replaceable, and if ever he or she will be replaced, then automatically the person replacing the first programmer will not have a hard time because he or she knows when or whatever the things that the first programmer did before she left off. So that's the importance of recording requirements. The third one is analyzing requirements. So this one is determining whether the stated requirements are very clear, are complete, unduplicated, concise, valid, consistent, and unambiguous, and resolving any apparent conflicts. And analyzing can also includes sizing requirements, meaning bantaon nyo kung paano mag-ano ka requirements. So it's not sobra, hindi man kulang. So sakto lang. Now, requirements analysis can also include, can be long and tiring process because during that time, you have a delicate and psychological skills are involved, and that the new systems changes and the environment and the relationship between people are affected also. And it is important to identify all the stakeholders. So take into account all their needs and ensure they understand the implications of the new system. So the job for the system analyst here can employ several techniques to elicit the requirements from the customer. So this may include the development of scenarios represented by a user stories and agile methods. And of course, the use cases. Guys, ang mga tao-tao nyo bala sa use cases ninyo. So it is important on the identification of use cases because the use of the workplace and the observation of ethnography, holding interviews or focus groups, or more aptly named in this context as requirements workshop or requirements review session, and creating requirements list. So the important thing about this is you have the prototyping. You can use prototyping for that. And in development for an example system that can be demonstrated to stakeholders. So where necessary, the analyst will employ a combination of these methods to establish the exact requirements of the stakeholders. And so that the system that meets the business model or the needs is produced. So you have the requirements quality can be improved through this and other methods. No. So the first one is visualization. This is using tools that promote better understanding of the desired end product, such as visualization and simulation. The second one is the consistent use of templates. This will be producing the consistent set of models and templates to document the requirements. And of course, documenting dependencies. So these are the interrelationship among requirements that may assume or have assumptions and congregations. So before we go to our activity 23, let me discuss briefly figure 18. So this is the perspective on requirements analysis. So you can see there, you have requirements analysis for the systems analysis and control. Then you have the functional analysis and allocation and the design synthesis. So the arrows that you can find here are the directions of what phases are you going to do. So like for example, if you from functional analysis and allocation, you're going to go to the requirements loop, requirements analysis. So you have the requirements loop there just because if you cannot find or satisfy the requirements for requirements analysis, you'll be able to do or to go back to functional analysis and allocation. So same as true with systems analysis and control balance, it says here that you can either use or go back to where you started from. So if you started from design synthesis, you may do so. You may design another conflicting ideas within the functional analysis for perspective for requirements. However, you may also go to functional analysis and allocation or to the requirements analysis per se. So depending on the need for systems analysis and control. Then you have also the verification coming from design synthesis, wherein you are going to go back or to bypass the functional analysis, where instead you have to go back to the requirements analysis. So this is all in all the process output and the perspective on requirements analysis. Okay. Now for activity number 23, you're going to have the title of our is fact checking. You're going to fact check. So fact checking is that you have to answer the questions that is being displayed on your screen. So you have 3 questions there. You have to answer it. Let me read to you the questions. So the first one is, what are the advantages and disadvantages of requirements analysis? You have to give at least 3 examples of each, the advantages and the disadvantages. So you're going to, I'm expecting you to make at least 300 words and 6 paragraphs, wherein you have 3 examples for advantages and 3 examples for disadvantages. The second one is referred to figure 18 there. So this one is figure 18. And you're going to explain the role of requirements analysis in software engineering. So you're going to write comprehensive report on its role, or at least 300 words for that one. Okay. For number 3, the question is, in your own understanding, does requirements analysis ease the burden of software development? Meaning to say, ginapahapos niya ang requirements analysis, ginapahapos niya ang paghimo ka software development, or in what aspect? So sa din perspective, no? Or do software engineers really need to undergo flexibility changes? Meaning, like for example, if you're going to plan something, a project, it must be that your project must be flexible, meaning it can adapt to any situation. It can carry out changes incitedly because these changes are needed to make the project successful. Or how can you do that? So you're going to explain it at least in 500 words. Okay. So that is fact check number 23. Okay, so no more at this time, guys, you don't need to program anything, no? So there's no more programming, but also you have to write it accordingly. So you have to research, you're going to fact check everything and put it into writing and pass it as PDF in your Google Classroom. Okay. So before we go to number 24 activity, let's discuss the second topic, which is the design process. So substantial disagreements exist concerning how designers in many fields, whether amateur or professional alone or in terms, produce designs. So like for example, take the case of Keith Dorns and Judith Discross. So these are both designers themselves, not designers nga ano guys, but software designers. So they argued that there are many ways of describing design processes, and they have to discuss the two basic and fundamentally different ways. So both of which have several names. The prevailing view has been called the rational model and the technical problem solving. So the reason between eccentric perspective, the alternative view has been called reflection in action and co-evolution, and the action-centric perspective. So for that, we have the rational model, and the rational model was independently developed by Herbert A. Simon, an American scientist, and Gerard Powell and Wolfgang Bates. So these are the two German engineering design theorists. So they said that designers attempt to optimize the design candidate for non-constraint and objective. And also, the design process is plan-driven, meaning may plano dapat. And the design process is understood in terms of discrete sequence of stages, meaning just like your SDLC, you have phases or the steps. If you cannot finish the step 1, you cannot go to step 2, no? And so on and so forth. So the rational model is based on the rational philosophy and underlies the waterfall method or the waterfall model. I think we're not going to dwell with waterfall or SDLC because that is part of your subject in systems analysis and design. However, according to this philosophy, the design is informed by research and knowledge in a predictable and controlled manner. So there's an element of research, and the sequence for the research per se is controlled in a controlled manner, meaning to say there's control there or limits that is imposed so that the activity or any processes is understood to be rational and acceptable. So let's discuss about the example sequence of stages. So you have the typical stages consisted of the rational model, which include the following. So number 1 is the pre-production design. Okay, so you just read this one, guys. No, so design brief, analysis, research, specification, problem solving, and presentation. The second one is the design during production, in which we have 2 stages, the development and testing. And the post-production design feedback for future designers, or the future design, that is number 3. And the stages are implementation and evaluation and conclusion. And of course, number 4 is redesign, wherein sa ano na kamo nga phase, cyclical nga phase, meaning version 2 na. And then if you are going to go again the stages, then version 3 na kamo pagkasunod. So that's why di ka mo matingala, especially with your antivirus softwares, wherein may mga versions na sila kay nag-undergo na sila ka development. So the development there is continuous. Why sila gaunta? So that's why may version 1, version 2, version 3, version 4. So muna siya. For the criticism of the rational model, you have the rational model has been widely criticized on 3 primary grounds. Designers do not work this way, and unrealistic assumptions. So between the two, designers do not work this way are very much out of the box. Unrealistic assumption doesn't assume that the goal must not be attainable. So the other way around. It's the other way around, meaning to say you set your goals and those goals must be met according to the plan that you created. So the same thing with you guys. I know that right now you are undergoing your thesis, no? And I assume that you are going to follow the steps of your proposal pa lang. Eventually, after the proposal, you'll be able to gain ground and follow the steps in systems development. So I think this will help you guys. You can actually quote this, or you may use another model. So most of the time, the models that are found in your systems development is the SDLC. Of course, this is the big umbrella, wherein you can choose among SDLC what process are you going to consider. So like, for example, if you choose waterfall, what is the advantages of the waterfall that is embedded for your system development? So the same thing with agile. And I think if your study is on applications or apps and websites, I think you may use agile. If your systems development is among electronics or probably database, then you use waterfall. So those are the things that needs perspective depending on how are you going to consider it and use it. Now, there are also action-centric models that is being implied here. We're not going to dwell about that. You can actually read here for figure 19, an example of business workflow process using business model and notation. So this is just a flow chart of that. And you can see the conditional statements there and the entities that is derived from. Now let's go to our activity number 24. So we are going to fact check again. Let me read to you the questions for activity number 24. What is the essence of the design and how it is applicable in programming? So you have discussed natin na kagina, but if you want to research it, you can have it, explain it, and at least 300 words. So the second one is give 10 design disciplines and their usefulness in computer hardware and software. So you have to research design disciplines and explain. And then what are the 3 types of design? For the 3 types of design, you're going to define each type and give their advantages and disadvantages. Okay? So those are, I think, is the much needed ano naton, guys, no? So this is the end of for this semester. This is the last lecture, and next week will be your final examination. Okay, so just take note. Tentative date for our exam is June 13, I think. Let me check. I think ang exam natin is 10 ata. So you can, pero I don't think we can do that. We're just postpone our exam to June 13, okay? So June 13 in the morning, so at 9 a.m. Okay? So the same process. Please get your. If you don't want to, guys, if you don't want to miss out your grades, please get your exams on time so that you will not comply sa inyong completion form. Okay? Okay, so thank you very much for listening, and please do comment present in YouTube so that for your attendance. Okay? So thank you and good morning.